In this video, we're going to look at two examples where we have more than one reactant. You'll see that diethylhydrazine is reacting with iodine. So the general rate law for this will include both of those things. To save time, I'm going to call this thing A, so I don't have to write out that stupid formula every time. So that's going to be K times the concentration of my diethylhydrazine to the M times the concentration of I2 to the N. And now we have to figure out what M and N are. So this is more complicated than with just one reactant, but what we do is we'll start by holding the concentration of one of these things constant. So I'm going to look at this diethylhydrazine, and for these two right here, you'll see that its concentration is not changing at all. Okay, and at the same time, the concentration of I2, as I go from one to the other, I'm not sure that's really clear to you, but you can divide that out, 0.362 divided by 0.25, and that's times 1.44. Okay? At the same time, the rate goes from 1.08 times 10 to the minus 4 to 1.56 times 10 to the minus 4. And again, if you divide that out, the bigger number divided by the smaller, 1.56 times 10 to the minus 4 divided by 1.08 times 10 to the minus 4, you get times 1.44. So we had this not changing at all, and then when this doubled, the rate doubled. So it looks like N is going to be 1. Okay, so we found the order with respect to the iodine. Okay, now I'm going to switch to blue, and we're going to look at these two where we keep the concentration of I2 the same, and we look and see what happens when we go experiment 3 to 4. So this concentration of diethylhydrazine goes from 0.2 to 0.3. That's times 1.5. And at the same time, the rate is times 1.5. So here we kept this constant. We doubled this. Well, we didn't double it, sorry. We made this 1.5 times bigger, and this is 1.5 times bigger. So what's M? Well, M is 1. So what you do is you hold one of them constant, and then you do the exact same thing that we were doing in the last video. So what is the order of the reaction? So I would say that it's first order, okay, with respect to diethylhydrazine. I'm going to write A again because I don't feel like writing it. It's first order with respect to I2. And the overall, all you do is add it. 1 plus 1 is 2. So we say it's second order overall. Okay? So my rate expression is K times concentration of diethylhydrazine times the concentration of I2. Okay? And these are both to the 1, and you don't have to write the 1. So then if we want to calculate K, we just go ahead and plug in. I'm going to go ahead and pick experiment 1, all this data right here. Okay? So 1.08 times 10 to the minus 4 is K times 0.15 times 0.25. And if you do that out, K becomes 0.00288 liters per mole per second. Okay, and again, we can talk about how to find these units in a nice shortcut, or you can do them out every time if you want to. And then what must be the concentration of diethylhydrazine so that the rate of the reaction is 5 times 10 to the minus 4th moles per liter per hour when I2 is 0.5. So, sorry, this should be an hour right there, not a second. Okay, so I'm just going to plug in. Remember, this is just a formula that we can use whenever we want to. So we're going to say that the rate is 5 times 10 to the minus 4, and that equals K, 0.00288, times the concentration we don't know, times the concentration of I2, which is 0.5. And if you do all that out, I believe you get 0.347 molar. Okay, so let's do one more example where we find the rate law. All right, an example. All right, I've got this compound reacting with hydroxide. So my general rate law is rate is K times the concentration, okay, of this junk times to the M times the concentration of OH minus to the N. And again, we have to find M and N. So I'm going to work with the blue here. I'm going to keep the concentration of that first thing constant. Okay, and I'm going to look and see what happens to the hydroxide. And look, it doubles. Okay? And at the same time, the rate didn't change at all. Huh, what does that mean? Well, this didn't change, this doubled, and this didn't change, so we say it's times 1. So what is N? Well, it's 0. 2 to the 0 equals 1. So N equals 0. Okay? Now we're going to look at these two right here, where I keep the hydroxide the same, and I look and see what happens to this other substance, which doubles, and at the same time, the rate doubles. So when I keep hydroxide the same, and I double this, my rate doubles. So what is M? M is 1. So my rate law is K times the concentration of this guy to the 1 times the concentration of OH minus to the 0, which of course is just 1, so we don't write it at all. So we just say rate is K times the concentration of this monstrosity. Okay, so hopefully you get the idea. In class you're going to practice a whole bunch more times. If you're like totally befuddled, come find me and I'll explain again.